Okay, so today, let's dive into the story of how we teach a computer to see. But we're not going to treat this like some dry, technical process. No, we're going to frame it as what it really is, an epic journey. We're going to follow an AI model from the moment it's created through its greatest challenge, and hopefully, to its ultimate triumph. It all really starts with this fundamental quest. When you or I look at a picture of a cat, our brain just gets it instantly. But a computer, all it sees is a massive grid of pixel values, just numbers. So the entire challenge of computer vision is right there in that question. How do we bridge that enormous gap? And this really breaks it down, doesn't it? On the left, our brain pulls together all these rich concepts, fur, whiskers, that classic cat shape, without even trying. But for the computer on the right, it's just a sea of numbers. There's no meaning there at all. Our entire journey is to teach that computer how to find the cat that's hiding inside all that data. To solve this, we don't just grab any old tool. We build our hero from the ground up. It's called a convolutional neural network, or a CNN for short. We're going to construct this hero completely from scratch, teaching it every single thing it needs to know. So our hero's first real power is something called convolution. And to do this, it uses a special tool called a kernel. Now, think of this kernel as a tiny pattern-hunting magnifying glass. It just slides methodically across the entire image, looking for the most basic, simple features you can imagine. Things like little edges, curves, and corners. The hero's whole strategy is this simple but really powerful four-step process. First, convolution, right? It finds all those basic patterns. Then, it uses a trick called pooling to kind of zoom out and focus only on the most important features it found. After that, it flattens all that information into one long list, getting it ready for the final step, where a fully connected network weighs all the evidence to make the final call. Is it a cat or is it a dog? And let me tell you, this is no small task. To get good at this, our brand new model has to tweak and adjust over 840,000 different internal dials, or parameters, to get them just right. I mean, imagine trying to learn a new language with a dictionary of almost 1 million words, all at the same time. It's a huge undertaking. So after some really intense training on its first set of data, our hero seems unbelievably powerful. It's acing all its practice tests. But there's a hidden danger lurking just around the corner, one that's about to expose a fatal flaw. On the images it used for training, our model is practically a genius. It's nailing them with 99% accuracy. Now, on the surface, this looks like a huge success, right? A sign that our hero is ready to take on the world. But what happens when our hero finally leaves the safety of its training grounds and has to face the messy, unpredictable real world for the very first time? Our hero has fallen right into the classic overfitting trap. See, it didn't actually learn what a cat is. Instead, it just memorized the specific cats and dogs in its training photos. It's like it crammed for the test, but never actually understood the concepts. And this slide shows you exactly why our hero failed. Just imagine if its training data, over there on the left, only had pictures of black cats and white dogs. Well, it might learn a really simple but totally wrong rule. If it's black, it's a cat. So what happens when it gets out into the real world, on the right, and sees a brown dog or an orange cat? It has absolutely no idea what to do. And the result of this? Well, it's devastating. When faced with a brand new set of images it has never seen before, its accuracy just plummets to a measly 72%. Our hero, who seemed so promising, has failed its first real quest. But just when all seems lost, a wise mentor appears. And this mentor doesn't offer a new weapon, but something much more powerful: ancient wisdom, a technique called transfer learning. This mentor is a legendary, pre-trained model, something like VGG-16. It's a true expert that has already spent countless hours studying millions of images from the massive ImageNet dataset. It already knows how to identify thousands of different objects, and it offers our hero all of that hard-earned knowledge. And the core idea here is so simple, but it's absolutely revolutionary. Instead of starting from a complete blank slate, we take the expert's highly developed brain, all those powerful feature-finding layers, and we just attach a small new decision-making layer right on top. We only have to teach our hero that one tiny final part of the task. Now, this is why it works so incredibly well. The expert mentor has already learned to see in layers, just like you see here. The early layers are experts at spotting simple lines and colors. The middle layers combine those into more complex shapes and textures. And the deep layers, well, they can actually assemble those shapes into complex object parts, like eyes, ears, and faces. And the difference in effort is just staggering. I mean, look at the image on the left. That's the long, hard climb of training from scratch. But on the right, with transfer learning, it's like we get a rocket boost. We freeze the mentor's millions of expert parameters and only have to train our new small edition. This saves a phenomenal amount of time, data, and pure computing power.
So, armed with the mentor's wisdom, our reborn hero faces the challenge one more time. But this time, the outcome is dramatically and beautifully different.
The final results really do speak for themselves. Just look at the leap on this chart. On the very same test data where it only scored 72% before, our hero now achieves over 91% accuracy. That's not just an improvement, that is a complete and total transformation. And here's the kicker. It achieves this superior result in half the time. It took only 5 training cycles to soar past its previous best, which shows not just greater accuracy, but just incredible efficiency. So what's the big takeaway here? The crucial point is that this isn't just some clever trick. It is a fundamental shift in how we build AI. Transfer learning makes powerful, state-of-the-art AI more accessible, more effective, and way more reliable for everyone, even if you don't have massive data sets or supercomputer in your basement.
Our hero's journey teaches us a really powerful lesson about learning, that building on existing knowledge is often so much more effective than starting over every single time. And that leaves us with a final thought to chew on. If we can do this for computer vision, what other incredibly complex problems can AI solve just by standing on the shoulders of giants?